Hello, this is Professor Megala. Okay, this is the first lecture of Math 1350, Mathematics for Elementary Teachers. The first chapter deals with problem solving. Problem solving is a very, very, very large topic. Is it a math problem? Is it a construction problem? Is it a seating problem? Or it's infinite. So how we resolve problems, that's the question. Because there is no one right answer. So a gentleman named George Puglia developed the whole process in which when we solve problems, we have to take it in sequence. You have to first understand what is the problem asking. What are you supposed to find? What are you given? What do you know? Do you know any formulas? Have you seen it before? And then put together a plan. If that plan works, great. If it doesn't, try another plan. That's what this first chapter is all about. Now, what I'm going to look at first in the homework problems, we have some interesting problems like find the sum of all numbers between 1 and 100. Inclusive. That means we use 1 and 100. So what we're looking for is from 1, 2, 3, 98, 99, 100. The sum means we have to add them up. So we have to add 1 plus 2 plus 3 plus everything up to 98 plus 99 plus 100. This problem actually was historically famous. In the 1800s, a mathematician named Carl Gauss was in school. He was a very smart kid, and he knew all the answers, and he was pretty bored. So the teacher tried to keep him busy, gave him this problem. Said, add up all the numbers from 1 to 100. Don't come back until it's done. That way he'd get back teaching his class. Well, within a few minutes, Gauss came back with the right answer. He was 8 years old. What he did was he looked for a pattern. Let's say we look at all the numbers from 1 to 4. If we add those up, what do we get? 1 plus 2 is 3, plus 3 is 6. We get 10. Let's say we add up all the numbers from 1 to 6. 1 plus 2 is 3, plus 3 is 10, 6, 15, 21. Now we said, let's look for a pattern. What he noticed, that if you look at the first and the last numbers, add them together, you get 5. And the next numbers, you get 5. And how many times do you have those pairings? You have 2. Okay, but remember, we only had 4 numbers in the set. So 2 times 5 is 10. Let's try that again. Look at the next set. 1 plus 6 is 7. 2 plus 5 is 7. 3 plus 4 is 7. So it's 7. How many times do they occur? 3 times. And we had 6 numbers. So he's figuring out a pattern here. Let's try it one more time. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. We know 1 through 6 is 21, 28, 36. Let's try it again. 1 plus 8 is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. How many times do they occur? 1, 2, 3, 4. So it happens 4 times, and we had 8 numbers. So this number related to the biggest number we had. Because remember, he did all of them, so we have 8 numbers. So how do we go from 8 numbers and get 4? How do we go from 6 numbers to get 3? How do we go from 4 numbers to get 2? Well, we take as many numbers as we have and divide it by 2. And then multiply that by 9, because that's what the pairs equal, and we got 36. So he figured then from 1, 2, 3, 4, all the way up to 98, 99, 100, it would follow the same logic. So we have 100 numbers divided by 2, so we have 50 pair of numbers. So what do they equal? 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98. So it was 50 times 101. So when you multiply those together, 5 times 1 is 5. 5 times 0 is 0. 5 times 1 is 5. And add a 0. Because whenever you multiply by tens, just add a 0 behind it. So he went to the teacher, says all these numbers equal 50, 50. So that upset the teacher because there goes his free time. So now let's see how this relates to what we got to do. If we had a sequence of numbers that are continuous, then it's pretty easy. We just do Gauss's method. But our homework is a little bit different. Find the sum of this pattern. So we have to come up with another example. So we had 3 plus 8 plus 13 all the way up to 103. It's going to be the same process. To find the sum, we take the number of terms that we have. N equals the number of terms. Number of terms, or number of numbers. What do we multiply? We multiplied the first term. This is A1, this is A2, this is A3, and so on and so forth. And this is our AN. This just helps us keep track of what these numbers are. So what we found this was, if we take the first and the last number, whatever it is, and divide by 2, times how many of them we have, then we have our sum. But the problem here is we don't know how many terms we have. So we had to come up with another process. Let's pretend our numbers were something easier. Say 1 plus 3 plus 5 plus 7 plus 9. We have to first come up with an equation. What we notice that each of these numbers, from 1 to 3, that's 2. From 3 to 5, that's 2. From 5 to 7, that's 2. From 7 to 9, that's 2. We call that the difference. We just call it difference because 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. So each pair of numbers, the bigger minus smaller, bigger minus smaller, bigger minus smaller. So we know our difference is 2. But let's look at these numbers. We start off with our first term is A1. That's our first term. Our second term, how do we go from there to there? Well, we add 2. So 1 plus 2. That gets 3. How do we get to our third number? This is A1, A2, A3, A4, A5. So the third one. Well, if we go from the second one, which is 1 plus 2, if we add 2 more to it, so 2 plus 2 is 4, yeah, it's 5. If we go to our fourth number, well, if we go to the one before there, which is 1 plus 2, and add 2 more, we get 7. 1 plus 2 plus 2 plus 2, and add 2 more. So take the previous one and add 2. Take the previous one and add 2. Take the previous one, add 2. Take the previous one. So it builds up from there. We see a pattern. Now, let's figure out a formula for this. How does this number fit in? Well, we know it's the number, it's the difference. If we notice, every time we added a difference to it. So it's 1 plus the difference. 1 plus twice the difference. 1, 2. 1 plus 3 times the difference. 1, 2, 3. 1 plus 4 times the difference. Now, here's the interesting thing. See our subscripts? That's 2. We only have one of these guys, 1D. If that's a 3, we have 2 Ds. If it's a 4, we have 3 Ds. So, and then 5. So if we had n Ds, n equations, then we would go 1 plus whatever the difference is. Remember, it's always 1 less. So it's n minus 1. So we start off with our first one. So our formula to find the last term, an, we have an. Start with the first one, a1, whatever it is. In this case, it was 1. Add the difference times n minus 1. Remember, n is the number of terms. Now, why do we do that? Because remember, back up here, our formula to find the sum is we had to know what n was. We know what the first and the last numbers are. We just don't know how many numbers we have between them. The first term is 3, the last term is 103. How many numbers are there between there? That's what we use this for. Remember, we have an, we have a1, we know the difference, we can figure out what n is. So in our question, look at our home. So remember, our formulas are an equals a1 plus d times n minus 1. And then to find the sum, it's n times the first term plus the last term divided by 2. So here's our A1, here's our AN. We first have to find N, so we use this equation to find N. So to find N, AN A1 plus D N minus 1. What's our difference? The difference is A2 minus A1. So 8 minus 3 is 5. Or 13 minus 8 is 5. So D, our difference, is 5. So A1 is 3. AN is the last number, 103. Our difference between each of these numbers is 5. Let's plug those in. So AN is 103. A1 is 3. D is 5. N minus 1. The only thing we don't know is N. And that's what we need for this formula. So let's find out how many terms we have. So to solve for N, first thing we have to do is get rid of the 3. Since that's added, we subtract. 103 minus 3 is 100. 5n minus 1. We have to get inside there, so get rid of the 5. Divide both sides by 5. 100 divided by 5 is 20. So that's gone, so we just have n minus 1. To get n by itself, we have to get rid of the negative 1. So we have to add 1 to both sides. So n is equal to 21. There are 21 terms in our equation. So the sum of our equation, the sum of the series of numbers, is n times a1 plus an over 2. Remember, n is 21. A1 is 3. AN is the last number, 103, divided by 2. Now just calculate that. So 21. 3 plus 103 is 106, divided by 2. 106 divided by 2 is 53. $53 times 21, 3, 5, 6, 10. 5 plus 6 is 11. So it's 1113, which is A. Okay, let's do it again with the next one. Number 2. Again, we're going to use the same equation. Since we're looking for the sum, we just don't know how many we have, so we use this equation. Remember, our first term is A1, our last term is AN. And the difference, 19 minus 7, is 12. 31 minus 19 is 12. So we know our A1 is 7, AN is 607, and D is equal to 12. So let's go ahead and calculate this. plug them in, solve for n. So an is 607, a1 is 7, d is 12, n minus 1. Remember, we have to find out what n is. First, get rid of the 7. Since it's a positive, we subtract 7 from both sides. (607 minus 7 is 600) equals n minus 1. Now we divide by 12. So 600 divided by 12 is 50, since there's no equals n minus 1. Add 1 to both sides, and we have n is equal to 51. Now we have everything we need, because to find the sum, we have to use n times a1 plus an divided by 2. N is 51. A1 is 7, that's the first number, plus 607, that's the last number, an, divided by 2. (51) 607 plus 7 is 614, divided by 2. That's 51. So 614 divided by 2. 2 goes into 6 3 times, and then 2 goes into 14 7. So it's 307. So 51 times 307 that's 7. 1 times 0 is 0. 1 times 3. 5 times 7 is 35. 0 plus 3 is 3. 5 plus 3 is 15. 7, 5, 6, 5, 1. So 15, 657. 15, 6, that's C. Alright, let's look at the next one. Find the following sum. Remember, we have to use this equation first. A1 plus D n minus 1. AN's the first term, so A1's the first term, which is 18. AN is the last term, which is 40. This is AN. The difference, how far are these numbers apart? 19 minus 18 is 1. 20 minus 19 is 1. So the difference is 1. Let's plug them in there. So we have 40 equals 18 plus 1 times n minus 1. Let's solve for n. Subtract 18 from both sides. So we get 22 equals, that's just a 1, so we have n minus 1. Add 1 to both sides. So n is equal to 23. So now we can find the sum of all the numbers. N A1 plus AN over 2. 23, 18 plus 40 divided by 2. 23, 18 plus 40 is 58. 23, so 2 goes into 5 4 times with 1 left over. 2 goes into 18. 2 goes in twice with 1 left over. So 2 goes into 18 9 times. So we have 29 times 23. 9 times 3 is 27. 6 plus 2 is 8. Over 1. 2 times 9 is 18. 2 times 2 is 4 plus 1 is 5. So bring this up. 8, 8 is 16. The answer is 667, which is A. So far, so good? Alright. Now the next one. This one's dealing with how many of a certain type of coin do we have. Unlike the first one, here we have to create a table. How many different ways can you make change for 25 cents coins using dimes, which is 10 cents, nickels, which is 5 cents, and pennies, which is 1 cent. Together, they have to equal 25 cents. So let's see. To get 25 cents, you can have 2 dimes, 1 nickel, 0 pennies. 2 times 10 is 20, plus 5 is 25. You could have 2 dimes, 0 nickels, and 5 pennies. Okay, we can have 1 dime, that's 10 cents. We can have 3 nickels, so that's 1 plus 15, or 10 plus 15 is 25. We can have 1 dime, 2 nickels, that's 10 plus 10 is 20, and we have 5 pennies, that equals 25. We can have 1 dime, 1 nickel, that's 15 cents, so we have 10 pennies. Keep on going. So we have 1 dime, no nickels, and 15 pennies. Okay. So we can't have it. So now we have 0 dimes. We have 0 dimes. We can have 5 nickels and 0 pennies. We have 0 dimes, 4 nickels, and 5 pennies. 0 dimes, 3 nickels, which is 15, and 10 pennies. 0 dimes, 2 nickels, and 15 pennies. 0 dimes, 1 nickel, and 20 pennies. 0 dimes, 0 nickels, and 25 pennies. So let's see how many that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can have 12 possibilities. So we have to look at all possibilities here. We're given these parameters: dimes, nickels, and pennies. All right, let's look at the next one. How many different amounts of money can you pay if you use 3 coins? Nickels, dimes, and quarters. So you have to use nickels, dimes, and quarters, and only have 3 coins. So we have nickels are 5, dimes are 10. So nickels, dimes, and quarters. So the total. Let's see. How many different ways? Because it's asking how many different amounts of money can you pay if you use 3 coins. There's limitations. So we can have 3 nickels, you can have 2 nickels, 1 dime, no quarters, 2 nickels, no dimes, 1 quarter. You can have 1 nickel, 1 dime, 1 quarter, 1 nickel, no dimes, 2 quarters, 1 nickel, 2 dimes, no quarters, no nickels, 3 dimes, no quarters, no nickels, 2 dimes, 1 quarter, no nickels, 1 dime, 1 quarter, no nickels, no dimes, 3 quarters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all the possibilities. What are called permutations. Different ways we can arrange them. It didn't ask us for amount of money. It's just how many. If we had 3 coins, these are the different possibilities. We have one with 3 dimes. We have 3 nickels, and we have 3 quarters, and all the other combinations. How many different amounts of money can you pay if you use 4 coins, including dimes and quarters? Dimes and quarters. We have 4 coins. So we have 4 dimes, no quarters, 3 dimes, 1 quarter, 2 dimes, 2 quarters, 1 dime, 3 quarters, no dimes, 4 quarters. 1, 2, 3, 4, 5. That's all you can do. Let's look at number 7. If 0.3 ounces of mustard is used for each 24 billion hot dogs, in each of 24 billion hot dogs, how many 8-ounce jars of mustard are needed? So what we have is, you have 0.3 per each hot dog. So this is the amount of mustard. We have 8 ounce. And we have 24 billion hot dogs. So we know for 8 ounces we have 24 billion hot dogs. So to solve this, cross multiply. We have 0.3 times 24 equals 8x. So 0.3 times 24 is 3 times 4 is 12, 6, 7.2. Remember, 7.2 billion. Divided by 8. So x is equal to 0.9 billion. So a billion is 1,000,000,000,000. So is that's going to equal, so if you have to move it one decimal place, it's going to be 999,900,000. It's C. So basically you have 0.03 divided by 8. This is for each of the hot dogs we have 8 ounces times 24 billion. Now this next one, you have the numbers 1, 2, 3, 7, and 8. How can you arrange them to get the biggest number? You know, to get the biggest number to multiplying, one of these has to be 7, the other one has to be 8. So these are all the possibilities of that one. But we can get a bigger one. Let's see, 700 over 80 or 800 times 70. Let's see which one's bigger there. So 8 times 7 is 56. 0, 0, 0. 56, 0, 0, 0. Okay, so that doesn't help much. Let's look at 72, 1 times 83. Because since these are the biggest numbers, that's the best way to go. Now, if the next one's a 2, that means the next bigger one has to be 3 on the bottom. So we have 82, this is just 82073. 73 times 82. 83 times 72. For speed purposes, let's see. I'm going to use a calculator real quick and just kick through these. So 720 times 83. That's 59,760. Next one is 820 times 73 is 59860. So this one looks better so far. 730 times 82. This is 59860. So they're the same so far. 830 times 72 is 59760. So it's got to be one of these two possibilities. So the clincher is this last number. So let's try 731 times 82 or 821 times 73. But remember, the first numbers have to be the biggest numbers. So we have 731 times 82, which is 5,942. 821 times 73, 59,933. So the biggest combination is start with the biggest numbers, but notice the numbers next to them. You start with the bigger one, the next one is smaller of the last three. 7, 3, 8, 2, and then the one at the very end. The one always has to be at the end because it's the smallest number. So 731 times 82 is C. That's pretty much just a straightforward application of it. Alright, now we have to do a division problem. Place the digits 1, 2, 3, 7, 8 in the division problem to get the biggest one. So, in order to get, basically, remember, A, this is the same thing as that. So whatever's here, the smallest number possible will give us the biggest answer, because we're looking for the greatest answer. So out of these numbers, A has to be 12. So we know D can't be right and B can't be right. So 873 over 12, 378 divided by 12. Obviously, since these are both the same denominator, the bigger number on top gives you the bigger number. So 873, so it's A. Remember, when you compare fractions, if the bottom number is the same, look for the bigger number on top, and that tells you the bigger answer. A word problem. Let's see. So whenever you have a word problem, always start off by drawing a picture. So a rectangle. A rectangle looks like this. Enclosed with 1,330 feet of fence. The length, let's write down what we know. The length of the field is, that's an equal sign, 45 feet longer than the width. So whatever the width is, we add 45 feet. And we don't know what the width is. So how long is the field? What we're looking for here is, it's an enclosed field. We have to add up all these sides. That's called a perimeter problem. The outer border is called a perimeter. We have the length, the width, the width. So it's the length plus the length plus the width plus the width. So perimeter is 2L plus 2W. That's the formula we're going to use. It's like if you had it in your classroom, if you had a border, that's how much material you need. You add up all these sides, and that tells you how much material you need. So we know the perimeter is 1,130. We know the length. Since we have two letters, we have to figure out what the relationship. Here's a relationship. We know that L is, anywhere you see an L, put a W plus 45. That's what L equals. Because notice we only have one letter now. Now we can solve it. Now we have the parentheses, so we have to distribute to get rid of the parentheses. So 2 times W is 2W. 2 times 45 is 90 plus 2W. Whenever you get rid of parentheses, always combine like terms. So this is like terms. So 2w plus 2w is 4w plus 90. We have to solve for w. But that's the only letter left in there. So we have to get rid of the 90 first. So it's 1040 equals 4w divided by 4. So our width, so we know half of that, we're going to 2 goes into that, 2 goes, so 520 divided by 2, because, and then 2 goes in there, 2 goes in there 5 twice. So again, you can use a calculator. 1040 divided by 4 is 260. So that's the width. 260 feet. But we know the length is 45 feet more than the width. So it's 260 plus 45 is 305. Let's test it before we go any further. So if this is 305, this is 305, this is 260, and this is 260. Let's see if it all equals 1130. So 305 times 2. $260 times 2, because there's 2 of those. So 610 plus 520 is 1130. So we know how long is the field. So we know the width is 260 and the length is 305. That's D. Right, so that's how you do the homework. On the exam, you may have questions like that, but then again, you may have questions that are, for example, if the one that's really popular, you have a triangle made up of a whole bunch of smaller triangles. So a question may ask you, how many triangles are there? Well, there's one big one. So there's one of them that has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So one of them has 13 spaces. Then look at some other possibilities. So break them up. It could be one. This is also a triangle. This is also a triangle. This is a triangle. So to break it down, it's all the possibilities. You may have one that says you have 4 people for dinner. Person A can't sit next to person B. Person B has to be next to person D. So how are you going to arrange it? So again, it's just trial and error. You have 4 people to sit at a table. A cannot sit next to B, but B has to be next to D. So there you have it. So just draw pictures and move them around. All right. So hopefully that answers your questions. And if you have any more questions, please contact me and we can go over some more. Have a great day.